What's up, my stat stars? Michael Princhak here, ready to give you a quick review of topic 3.3 over random sampling and data collection. Now, the primary focus of this topic is teaching you the 4 different ways of selecting a sample at random. They're all pretty cool. They all have their advantages. They all have their disadvantages. I'll talk about a couple of those things in this video. But again, the main purpose is just getting across to you the 4 different types of selecting a good random sample. All right, let's dive into it right now. Now, the first thing I want you to know, there's 2 ways that we could sample. We could sample with replacement or we could sample without replacement. Now, when we sample without replacement, that means that when an item or object is selected, it cannot be picked again. So imagine a bag and we select an object out of that bag and we do not replace it. That simply means that that object cannot be picked again. Now, if we sample with replacement, that means that an object can be picked more than once. So if we take an object out and we sample it, we look at it, whatever, we put it back before we select our next object, that is sampling with replacement. Now, which is better, which is worse? Well, right now, there really is no better, is no worse. It's just 2 different ways to sample. It does make a lot of sense so that you don't want the same object picked twice for a sample. So it does make more sense to sample without replacement. Now, when it comes to random sampling, there's 2 big rules. The first is it's got to be a random sample or else throw it out the window. It's not worth anything. The second is that the sample should be representative, meaning that it should represent the population that it came from. So as long as those 2 things are true, then, well, your sample should be good. Now, there are 4 ways that we could select really good random representative samples. The first is a simple random sample. The second is a stratified random sample. The third is a cluster random sample. And the fourth is a systematic random sample. Let's talk about each of them right now. The first random sampling technique is known as a simple random sample, or SRS for short. And this is actually probably the most common type of random sample that's out there. Let's talk about the definition real quick. A simple random sample is a sample in which every group of a given size has an equal chance of being chosen. This method is the basis for many types of sampling mechanisms. Now, the key idea, as mentioned, is that every group of a particular size has the equal chance of being picked. So, for example, if my population of interest is students at Smithville High School, big, huge, large high school, 5,000 plus kids. Okay, if I want to get samples of size 40, well, any sample of size 40 has an equal chance of being picked. That's exactly the definition of a simple random sample, meaning that I could get all 40 girls, I could get all 40 boys, I could get exactly 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors. I could get all 40 kids that have blonde hair, I could get all 40 kids that have black hair, all 40 kids could have blue eyes, all 40 kids could be seniors. The idea is that any group of 40 has an equal chance of being picked. Now, you might be thinking, well, wait a minute. I don't want to get all 40 girls. I don't want to get all 40 boys. I don't want to get all 40 seniors. You're right. I agree. That could be a potential disadvantage of a simple random sample, but that's exactly the definition, is that any group of size 40 could be picked. Now, I'll be honest, a group of all 40 seniors being picked would be really unlikely because the school is filled with freshmen, sophomores, and juniors as well. So it's more likely that some of them are going to be in your sample. And that is why we don't necessarily always worry about, well, what if we get all 40 seniors? Well, it could happen, but it's kind of unlikely. Now, a simple random sample is exactly that. It's just very simple, and we trust the whole simpleness of it that we're going to get a nice representative sample. Yes, I know in the back of your head you're thinking, but I could get 50 seniors or I could get 40 seniors. You're not wrong. But it's simple, it's random, so we should get a nice mix. Is it going to be a perfectly even mix? Probably not, but it is going to be a nice mix. Now, how do we actually go about getting a simple random sample? Well, there's 2 methods that are really popular. The first that a lot of kids want to jump to is just using a hat. Put everybody's name on a piece of paper, put those pieces of paper into a hat, and pick out 40 of them without replacement because we don't want the same kid picked twice. We need 40 different kids. Yes, that method works perfectly as long as you describe it very well. But another method that I like is a little bit more, well, statistical. Here's the idea. Everybody gets a number. Now, everybody needs the same type of number. So if I have 5,000 kids, that means that a lot of kids are going to have 4 digits in their number. And if some kids have 4 digits, then every kid needs 4 digits. So the very first kid that I'm going to label would be 0001. That way he or she has 4 digits, just like person 4,978. Then what you're going to do is you're going to use what's called a random number generator to pick the numbers at random for you. Now, what is a random number generator? It's basically a computer program that just spits out random numbers. Your calculator actually has one built into it, and it just picks out random numbers, and you could look at any 4 digits at a time to get your numbers to be picked. Now, you need to do 2 important things though. You need to ignore repeats. If the same number gets picked twice, well, we don't want the same number picked twice because we want 40 different kids, so we just ignore it. Or if a number that nobody has gets picked, we would ignore it as well. So if we only have 5,000 kids in the school, well, what if number 6948 gets picked? Well, nobody has that number, so we just ignore it. And then the third and final step is once we have our 40 different numbers selected, those 40 corresponding students will be selected to be a part of our sample. And that is as simple as it is. The advantage is it's simple. The disadvantage is, I might get 40 seniors. You're right. But if you're not worried about that, because I'm not worried about that, well, it's simple. It should produce a nice random sample. Simple random samples are by far the most popular. The next random sampling technique is known as a stratified random sample. Let's talk about the definition. A stratified random sample involves the division of a population into separate groups called strata, based on a shared attribute or characteristics, homogeneous grouping. If people are put into the groups because they have something in common or they have something that they share, that's called homogeneous grouping. Now, within each stratum, a simple random sample is selected, and the selected units are combined to form the sample. So to make that definition really simple, here's what we do in a stratified random sample. We take our population and we divide them into groups. Homogeneous groups where everybody in a group has something in common. That means the groups are different between, similar within. Then what we do is we conduct a simple random sample in each group by taking some kids at random from each group. That's going to give us a nice sample to combine all together for our large sample. Okay, let's give a quick example. Smithsville High School, 5,000 some kids. Let's break them into grade levels. So we're going to put all the freshmen together, all the sophomores together, all the juniors together, all the seniors together. There's my homogeneous groups. The shared attribute is what grade level they're in. Then I'm going to do a simple random sample taking some kids from each group. I could randomly take 10 kids from each group to get my random sample of 40 in total. Now, there's no rule that says you have to take the same number of kids. For example, if you have way more freshmen, maybe you take 12 freshmen and only 8 seniors. Whatever, it doesn't matter as long as you take some kids from each group. Now, 2 more important things I want to mention about this. Why? Why would we do this? It guarantees representation. Remember, one of the disadvantages of a simple random sample was there was that small chance of what if I get all 40 seniors? Well, I mean, I agree. It's possible because anything's possible in a simple random sample. So if you're really that worried about getting all 40 seniors, you do a stratified sample because now we're not guaranteed to get all 40 seniors. We're guaranteed to get a mix of freshmen, sophomores, juniors, and seniors, which is going to create that representation that we crave in a really, really good sample. Now, most kids at this point might be thinking, well, why would I ever do a simple random sample? Wouldn't a stratified always be best to get representation? Well, listen, remember, in a simple random sample, it's simple. You should get representation. We're just trusting the laws of probability that you should get a nice mixed up sample. But if we really don't want that to happen, or really scared that we might get something weird, that is when you could go ahead and do a stratified random sample. All that matters is that you take some from each group at random. Now, the next big thing that I want to talk about when it comes to stratified random sample is what variable do you stratify on? The example I gave you, I dealt with grade level. That's what I chose. Now, what if I chose gender? Okay, separate your population to boys and girls and then pick 25 or 20 of each, whatever you want. Okay, how do you know what variable to use? Well, you pick one that makes sense for what you're talking about. So, for example, if what I'm talking about is views on college, freshmen, sophomores, juniors, and seniors might have very different views on college. Seniors are worried about it, freshmen aren't. So again, if you want to get a nice mix of views of college, then you definitely want to stratify getting that nice mix. Because if you don't stratify, you might get all freshmen or you might get all seniors and then you become one-sided. Now, If that doesn't matter, let's give another example. Maybe your survey, maybe your research, maybe your study deals with hair and you're really interested in hair. Whatever reason, I don't know why, I don't know what you need to care about hair for, but let's just say you care about hair. Well, then maybe you want to actually stratify by hair color or hair type. Then it makes way more sense to put all the people with long blonde hair together, all the people with short brown hair together, and then you take some from each group, guaranteeing you nice representation when it comes to hair. So if that's what you care about, that's what you stratify on. Or maybe you think gender matters most. Maybe you're going to ask some type of political question and you think that boys and girls are going to respond very differently and you want to make sure you get a nice representation of boys and girls. So you stratify based on boys and girls, create your stratus, pick out 20 girls at random, pick out 20 boys at random, boom, you got a nice sample. So again, how do you stratify? It's based on a characteristic of your survey, of your study that you think matters and you want to get the representation. That way you get a really good sample. The third type of simple random sample technique is a cluster random sample. Let's talk about the definition real quick. A cluster sample involves the division of a population into smaller groups called clusters. Ideally, there is heterogeneous within each cluster. That means within each cluster, they're very, very mixed up. Each cluster is very, very different within. And clusters are similar to one another in their composition. So this is actually the opposite of stratified. What we have is groups, but these groups are hetero within, which means they're very similar in between. So all of the different clusters we're making are nice mixes of your population, which means that they're all very similar between, very different within. A simple random sample of clusters is selected from the population to form the sample of clusters. Data are collected from all observations in the selected clusters. Okay, at this point, a lot of students get very confused as what's the difference between a simple random sample, a stratified, or a cluster. So let's make sure we explain what a cluster sample is first, really, really well. Okay, we have our population, we break them into groups, but the groups are like mini populations. Each group is a nice, small representation of that population. And the other group, it's another small representation of the population. And the next cluster is another small representation of the population. So I have a bunch of small representations of the population. Then I label my clusters, right? Every cluster gets a number. I use my random number generator and I pick one or two, however many clusters you want. And every single person within the clusters picked becomes part of my sample. Now you might be like, okay, hold on. Why would I want to do that? Well, think about it. If your clusters are mini representations of the population, whatever cluster gets picked would be great to represent your population. Now, I gotta say this too. The best scenario of using a cluster sample is when your population is already broken down into these nice heterogeneous groups. Let me give you an example. Maybe at Smithville High School, there are 4 lunches. Each lunch is comprised of boys, girls, seniors, freshmen, sophomores, juniors, rich kids, poor kids, different ethnicities, different cultures, different thoughts, different beliefs, different hair colors, everything, right? Each lunch is like a mini population. Then what you do is you simply label the 4 lunches, 1, 2, 3, 4, use a random number generator, ignore repeats, ignore numbers that no lunch has, and the lunch that gets picked is your entire sample. And that means that that sample is now representative of the population because it was like a mini population. I didn't take the time to make those groups. Those groups were already kind of self-created, and that's what makes great clusters. Now, a lot of kids have a very hard time deciphering between cluster versus random sample. At the end of this video, I'm going to try to give you one giant big example that better explains it, but both of them involve breaking the population into groups. Stratified, we break them into homogeneous groups, so the people within each group have something in common. Cluster, we break them into heterogeneous groups, so the people within each group are all very, very different. But here's probably the biggest difference between the two. In a stratified random sample, we visit each and every group, taking some kids at random, some objects at random from each group, from each. In a cluster random sample, we have our clusters, and we don't take people from each cluster. No. We take 1 or 2 of the clusters to become our entire group. And because those clusters were mini representations of the population, whatever clusters get picked would make great sample so we have that representation. So hopefully I explained that well, but when we start taking a look at another example at the end of this video, I think it might make even more sense. Now, what's an advantage to a cluster? Why would I want to do it? Well, maybe your groups are already created and it's a lot faster to just label the groups and select one or two groups than it is to label all the kids in the freshman group, random sample some of them, label all the kids in the sophomore, random sample them. Again, you're randomly sampling the groups, the clusters, not the people. Another difference. So an advantage is it is way faster if you already have these kind of self-created groups. Stratify has a tendency to take a lot of time because you got to do multiple simple random samples from each group. The fourth and final simple random sampling technique is called a systematic random sample. This is actually the easiest to recognize and probably the most or the least used, to be quite honest. All right, a systematic sampling has this definition. A systematic random sample is a method in which sample members from a population are selected according to a random starting point and a fixed periodic interval. Now, a lot of kids read that and they're not quite sure what they just read. It's as simple as this. Maybe I get a class list of all 5,000 kids at Smithfield High School, and I have a random starting point, and from that random starting point, I pick every 10th kid. So every 10th kid on the list becomes part of my sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that kid's in the sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that kid's in my sample, and I just keep going. So again, typically when you see a systematic design, you're going to see every 5th kid, every 10th kid, every 30th kid, every 100th object, whatever it is. That's a sign of it's systematic. And it's a great way to select the sample. You just have to make sure that where you start is random, and then from there you pick every so many kids. And it's really good, it's really simple, it's really easy, but again, it's honestly not the most commonly used, but it is the easiest to recognize. Now, to better understand these 4 different sampling techniques, let's look at a couple examples. In this first example, my population of interest is all the employees at a large hospital. Okay, simple random sample. Every single person who works at the hospital gets a number. I'm going to use my random number generator to pick, I don't know, 100 numbers if that's what I want for my sample. And I'm going to ignore repeats because I don't want the same person picked twice. And I'm going to ignore numbers that nobody has. Then the 100 numbers that are selected and those corresponding people will be part of my sample. Simple and random, exactly what I want to do. And it should produce a representative sample. Now you can easily argue, well, what if you get more nurses than doctors or more janitors or more technicians? Okay, I mean, you're not wrong, but that's where I'm like, listen, if it's truly random, I should get a roughly nice mix of all the different people that work at the hospital, and that would make a really, really nice sample. Now, a stratified random sample would be, oh man, I'm gonna ask some survey questions that janitors might respond very different than doctors or nurses or technicians. So I really wanna make sure that my sample is representative of all the different types of jobs. Okay, this is where you're going to break your employees into the type of employee that they are. So all of your doctors go into a group. That's going to be a homogeneous group because they all share a characteristic. They're doctors. All the nurses go into a group. All the techs go into the group. All of the orderlies go into the group. All of the nurses go into a group. I think I said that. All the janitors go into the group. Whatever. You break groups based by the employee classification. Then you're going to visit each and every group and take out a certain number randomly from each group. Now that's going to be very time consuming because you got to visit each group and do multiple simple random samples, one from each group, but it's going to guarantee you that representation that you're craving because you know that your survey questions might be very differently answered from a janitor versus a nurse versus a doctor. But again, you broke them into these homogeneous groups and then you took some from each group. And as I said earlier, you don't have to take the same number from each group. If you have way less doctors, then maybe you take less doctors. And if you have way more nurses, you take more nurses. Now, a cluster random sample would be something like the floors of the hospital. Each floor has a nice mix of employees. Every floor's got janitors, every floor's got nurses, techs, doctors, you name it. Then, instead of picking people, you pick a floor. So maybe there's 10 floors on the hospital. Every floor gets a number. Use a random number generator and pick 1 or 2 floors. And every employee on those floors gets picked for my sample. Now, because each floor was like a small population of the different types of jobs, I'm going to get that representation that I want regardless of what floor gets picked. The advantage there is the actual selection is way easier. All I got to do is label 10 floors and pick one or two of them, and then I'm done. It's so much easier. Now, what happens very often is that a lot of people will kind of mix up cluster and stratified. So one thing they'll do is they'll say, oh, I'm going to break my population into their job. Again, nurses, doctors, and so forth. And then they're going to be like, well, then I'm going to label those groups and select one of them. Okay, now that's a cluster because you're not selecting people from each group. You're just selecting one of the groups. So now you thought you were breaking your population into stratas based on them being very similar within each group, but then you did a cluster because you picked one of those stratas to be your entire sample, which would be very bad because then you maybe pick the nurses and then your entire sample is all nurses, and then you're not going to get the different opinions and different thoughts and different feelings from those other job classifications. So don't mix them up is my point. All right. Now, the final one is a systematic. This is maybe where I just get one giant list of all the employees. I pick a random starting point, and then maybe it's an alphabetical list or something like that. Get a random starting point, and then pick every 50th person on the list. And once I have a certain number of people, and I have my sample, and I'm good to go. And in this second and final example, let's just say I'm a geologist. So I'm highly interested in getting a nice sample of rocks through this large plot of land that has rocks spread throughout it. Now, notice this. Every situation is a little bit different, and based on the situation, based on the population, there might be disadvantages, there might be advantages to the different sampling techniques. So this is a great example to understand that. Now, notice how the population is set up. We have 15 plots of land, 5 across the top where we see a lot of large rocks, 5 across the middle where we see a lot of medium-sized rocks, and 5 across the south where we see a lot of small rocks. Now, if I do a simple random sample, very easy, every single rock, no matter where it's at, it has to get a number. Use my random number generator, ignore repeats, ignore numbers that nobody has or no rock has. And I'm going to pick out, I don't know, let's just say 100 rocks, and the 100 numbers in those 100 corresponding rocks will be a part of my sample. Okay, pretty easy. Now you could argue, but wait a minute, what if all 100 rocks come from those plots in the north and they're all larger? That's not going to be representative of all the rocks. You're right. That is possible under a simple random sample, but if I'm going to do a simple random sample, I'm putting my full faith, my full trust in the randomness procedure. That's probably not going to happen. Even though it could, it would be highly unlikely. But if I'm really that worried, maybe I do a stratified random sample where I have these 15 plots. I visit each plot, taking out 5 or 10 rocks, however many you want, from each plot at random. Again, I'm visiting every single plot and randomly taking some from each. From each is the key thing there that makes that stratified. Now that's going to be really, really advantageous, time consuming, I guess that'd be the disadvantage, but advantageous because I'm guaranteeing myself some different rocks from every plot of land, and I'm guaranteeing a nice mix of small, medium, and large rocks. Now, cluster random sample would probably be a bad idea here. If I leave the 15 plots of land the way they are, and I just label the plots, and I say, okay, I'm going to pick out 2 plots at random, so I'm labeling the plots, I'm not labeling the rocks, and 2 plots are going to be picked, and every rock in those 2 plots are going to be in my sample. Okay, that's definitely a cluster sample, but that would not be a good idea here. Because what if the 2 plots of land are both in the south? Easily could happen. So now my entire sample is made up of small rocks and I don't have the representation that I really, really want. So in this scenario, yes, did I do a cluster sample? I sure did, but it wasn't a very good cluster sample. Remember, when we do a cluster sample, we want each group to be like a mini population. Now, what some kid always says in a problem like this is, well, why don't you make the clusters? Why don't you make a bunch of clusters that contain small rocks, medium-sized rocks, and large rocks? That way, when you go and you select your groups, it doesn't matter which group gets picked, you're going to get that nice representation. Okay, first, listen, you're absolutely correct. You can create your clusters and make them mini populations. That way, whatever cluster gets picked is a great sample. But when it comes to rocks, you gotta move them to create these groups. You gotta put all these different rocks in one group and all these different rocks in another group, creating these clusters, and I don't wanna move all those rocks. So again, it might be possible to do it that way, but it wouldn't be well, logically possible. It wouldn't make sense to do it that way. So again, this is where you have to really take the time to understand there are advantages and disadvantages for each sampling method depending upon the question that is to be answered and the population from which the sample will be drawn. Now, I can't possibly go over every single type of scenario, every single type of situation, and every single disadvantage and advantage. You really need to see a bunch of examples in class to get a good feel for when do I do this or when do I do that. But what you need to understand from this video are just simply what the 4 different sampling techniques are, what they look like. That way you could recognize them. And then when you recognize them, you could think, is that a good idea or is that a bad idea? Would I be okay if that happened or would I not be okay if that happened? And then you could pick really what's best for your particular scenario and your particular question. All right, that's it for this topic. See you later.